So this is the fourth circle theorem lesson today. This is the alternate segment theorem. Okay, so this is the potentially the most complicated one of the bunch. Okay, but we're gonna work through it and see how we get on with it. So let's jump right in. So unfortunately, there's no beating around the bush. The definition of this circle theorem is a bit of a doozy, but it's much easier to see the theorem in action rather than to try and understand the definition. Okay, but we're going to go through the definition just so we cover all bases. So let's read it. Let's read the definition first. The angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. Right, now that's a bit of a mouthful. Okay, so we're just going to work through this step by step just so we can understand the proper definition, and then I'm going to try and give you a slightly simpler definition. Okay, so first of all, the angle between a tangent and a chord. Okay, so we've got our tangent. Our tangent's the red line. Okay, now I'm going to draw all the useful chords in this lesson in a blue line. Okay, if you remember, a chord is a line. Oh, that's a curvy line. A chord is a line that is in a circle and it touches 2 points. Okay, but it doesn't necessarily have to go through the center. Okay, so this line is a chord. Okay, so the angle between a tangent and a chord. So you can see now we have got an angle between the chord, which is in blue, and the tangent in red. Okay, so let's call this angle x. Let's call this angle x. Now, the angle between the tangent and the chord through the point of contact is equal to the angle in the alternate segment. So this is where the wording gets a bit tricky. Okay, but we're just going to hang about, bear with it. So let's use a slightly darker red. Okay, so basically what it's saying is if we have another point somewhere on the circle, call it here, and if we joined up this point to the 2 points of the chord on the circle, so we get one there, and we have another one here, this angle we've created here from that point that meets the 2 points of the chord, this is the angle in the alternate segment. Okay, and this theorem proves, or this theorem says, that the angle between the chord and the tangent, this angle over here, is the same as this angle here. Okay, now the wording is quite complicated, so here's the best definition I could come up with. The angle between the chord and the tangent, so we've got our chord and we've got our tangent here, we've got our chord and our tangent down here, is equal to the opposite angle inside the triangle. Okay, and basically all I've got with this definition, this is how I visualize it, is when I've got my given angle here, so I've been told angle x here, I highlight the chord, or the line that isn't the tangent that makes that angle. I then find the angle that is opposite this line here, and I know that that angle that I'm pointing to is the same as the original given angle. Okay, so unfortunately it's a bit of a wordy, it's a very complicated theorem just to put into words. Okay, but hopefully using a few examples, it's going to be much easier to show you what it is. Okay, so let's jump right in. So if we're given a shape here, and we can see, as you can probably see already, it already looks like we've got a triangle going on here. Okay, so we've got our tangent, and say we were given this angle here. Okay, so we need to find out. So the theorem says that the angle in the alternate segment is going to be the same as this angle if we label this x. Okay, well, first of all, let's color in the chord of this angle. Okay, so this is the angle between the chord and the tangent. This is our tangent. Therefore, this line must be the chord. Okay. Now, what angle is opposite this line here? Okay, so which angle is opposite it? Well, it can't be this one because it's adjacent to it. And it can't be this one because it's adjacent to it. So it's got to be this angle here. Okay, so that angle, the green angle x, is equal to the angle x, the blue angle x in the top corner. Okay, because it's the angle opposite the chord. Okay, let's have a look at another one quickly. So here we go. So say we were given this angle here, we're going to call it y. So this angle is created by the tangent and this line here, okay? So this is going to be our chord. So which angle in this triangle is opposite to this blue line? Well, it's going to be this one in the top left here, okay? So this would be angle y. Okay, so these are the corresponding angles. These are the two angles that match, okay? The first angle is between the chord and the tangent, and the second one is in the angle, in the opposite angle inside the triangle, okay? And just one last time, say we were given the angle down here, we'll call that Z. This angle is between the chord, the blue chord and the tangent. Therefore, the angle opposite this is going to be the angle in the top right of the triangle. Therefore, that's going to be angle Z. So therefore, they're going to be the angles that match up, okay? So before we use any numbers, just so we get really confident at finding the correct angle that matches up, I've got a little quick set of questions, okay? So for each of these circles, say we were given the value of the green angle, what would which angle in the triangle in the shape would be equal to it, okay? So for example, if I do the first one for you, so we've got our tangent line in red, and the green angle is between the tangent and this side here, okay? So that's our chord. So which angle, A, B, or C, is going to be equal to the green angle? Well, in this case, it's going to be B, because angle B is the angle opposite our chord, okay? So the first one is B, okay? Now pause the video, have a look at the next three diagrams and see if you can think which letter is going to be the same angle, which letter is going to have the same value of angle as the green angle, okay? We're not dealing with numbers yet, we're just seeing if we can spot the right angles, okay? So pause the video and have a little think. Okay, so for the second one here, so we've got our green angle between the tangent and the chord is this blue line here, and the angle opposite the chord is A. So the second one, angle A is the same as the green one. For the third shape, we've got our green angle between a tangent and the blue chord here, if we just color that in. And the angle opposite the blue chord is C. And then for the last one, we've got our green angle. It's between the tangent and this chord, just color in the chord now. And the angle opposite that is angle B, okay? So hopefully if you were able to spot the alternate angle in these questions, this lesson should be a little bit easier, okay? Now let's throw in some numbers. Hopefully the numbers will make a little bit more sense now. Okay, so we've got our first angle, and we're being asked to find the size of angle A, okay? Now, if we look at our shape on the left here, we see we're given an angle already. Now, just to color it in so it looks familiar to the last time, it looks like we've got a tangent here, which is our red line, okay? And this angle is between the tangent, and we know it's going to be between a tangent and a chord, okay? So we're going to label this other line, rather than label, just going to color it in our classic chord blue, okay? So we can see we've got an angle between our chord and our tangent, and we know that the alternate angle is going to be equal to this angle between the chord and the tangent, okay? So what angle is opposite to the chord? Oops, let's change to blue. Well, it looks like A is the opposite angle. So that must mean that A is going to be equal to 80 degrees, okay? And that's it, we're done. A is 80 degrees. Simple as, okay? Let's have a look at another example. So now we need to find the size of angle B. So this just happens to be the other side of the other angle of the same shape, okay? So again, let's use our colors to help us break down this question. So it looks like we've got a tangent here, our tangent in red. And we can see that angle is between the tangent and another line. Well, that line, we're going to call that line our chord, okay? Now, in the triangle, in the triangle that's inside this circle now, which angle is opposite the chord, the line that is our chord? Well, it's angle B. Therefore, angle B is equal to 70 degrees, okay? Simple as. So therefore, in this case, B equals 70 degrees, okay? So once you know what you're looking for, these questions are very easy to answer, okay? But the reason this is one of the more difficult ones is because it's quite hard to actually realize which angle you're looking for, okay? But hopefully if you label up your triangles nice and simply, the tangent and the chord, makes it much easier to find the right angle, okay? Now, obviously, if the questions were just this, they'd be a little bit too easy, okay? So the questions will sometimes have multiple layers to them. So let's add a few more layers to the questions. So we need to find the size of angle X, okay? So just like we've always done, true and faithful, let's find our tangent. Well, this looks like our tangent here. I'm going to draw that in a nice red line, so I can see where that is. And I can see there's an angle between the tangent and a line in the circle. I'm going to call that line our chord, okay? So this is our blue line, the chord. Lovely. But hang on a minute. I don't know what angle X is. So even if I did know what angle is going to be equal to, I don't even know what X is. So for now, let's find what angle inside the triangle is going to be equal to X. Well, I've got my chord here, and the angle opposite the chord is this angle here, okay? Let's just call that X for now, because I know it's going to be the same as the angle between the chord and the tangent, okay? So I know this is going to be X. But how am I going to find this angle? Well, thankfully, we've already got a triangle made for us. See, before we even started this question, you might have noticed that there was a lovely triangle waiting for us, okay? Therefore, now, let's change to a red pen. Angles in a triangle equal 180 degrees. Therefore, X plus 20 plus 80 is equal to 180. X plus 100 is equal to 180. Therefore, X is equal to 80 degrees. Okay, so obviously, using the alternate segment theory, we were able to find the equal angle outside the triangle, and then using the numbers inside the triangle, we were able to answer the question. Okay, let's have a look at another one. So we need to find the angle C first, okay? So before we do anything, let's use our alternate segment theory to find which are the equal angles, okay? So I've got my tangent here in red, and the angle, the other line that makes angle C is going to be our chord, so I'm going to color it this blue angle here. Lovely. Now, which angle is opposite our chord? Well, it's going to be this one over here, isn't it? So let's call that angle C. Okay. Now, if I look inside the triangle, I have got a triangle in this question again, but I don't think this is going to help me actually, because I only know one of the angles is 40 degrees. So we're going to ignore the fact that it's a triangle for now. But what other information can I use to help me figure out what angle C is? Well, if we look to the right of our new angle C, we can see we've got 85 degrees. And you should remember from quite an old lesson on shapes a while ago, opposite angles are equal. Opposite angles are equal. Okay, and all that means is if you have a cross like this angle will be the same as the opposite angle. And if you had a different angle up here, say this was Y, it would be equal to the opposite angle below it, okay? So because opposite angles are equal, that must mean that C is equal to 85 degrees, okay? Because our new angle C is opposite 85 degrees, so they have to be equal to each other, okay? So it's not much writing down and working out for these questions. It's just filling in the picture and filling in the information, okay? Let's have a look at one more example. So we need to find the size of angle X, okay? So before we go anywhere, let's draw in our tangent and our chord so we know what our equal angle will be. So here's our tangent here, our lovely red line. And the angle, the angle is between the tangent and this blue line here, okay? So this is our chord. Now what angle is opposite our chord? Well, if we have a look over here, it's going to be this angle here, okay? And now we're only told our angle between the chord and the tangent is X, so let's label up this equal angle as x as well. Now, how are we going to answer this one? Well, if you look carefully at the shape, you should have spotted these black lines going through the line, okay, or these extra lines going through the lines, okay? And that means we are dealing with an isosceles triangle, okay? Isosceles triangle. And that must mean that the two angles at the bottom have to be the same, okay? And because all the angles have to add up to 180 degrees, and because these two angles at the bottom are the same, so let's also label this angle is x here, okay? Now these all have to add up to 180 degrees, so that must mean that 2x plus 86 is equal to 180. That means that 2x is equal to 94. And if you divide both sides by 2, that means that x is equal to 47 degrees. Okay, so it's just a bit of problem solving, completing the picture, and just using the information that you know, and then just filling in the rest of the angles and information. Okay, so here comes the main task. So pause the video, and to take your time, the first step for every question should be finding the angle between the chord and the segment, finding the chord line, and then recognizing the alternate segment, because you know those two angles are going to be equal, okay? And then most of these questions is just finding the rest of the angles in the triangle, okay? So pause the video and have a go with these questions. Okay, so here are the answers. Very well done if you got them right. Oh, I think, sorry, for question F, x is 60. I forgot to label that. X is 60 because it is an equilateral triangle, okay? So x has to be 60. So hopefully you got all those right. And if you look at the questions, I've drawn the tangent line as red and the chord in blue, just like I've done the whole lesson, okay? So that should hopefully help you see where I've got my numbers from, okay? Now let's have a look at the checking question. So you need to find the values for x and y. Okay, this is quite a tough question, this one, so really take your time with it, okay? So first of all, use the alternate segment theory to put some of the values equal to each other, and then you have to do some maths wizardry with the numbers then, okay? So pause the video and see if you can find the values for x and y. Okay, so let's go through the answer then. So let's look at angle 80 first, okay? So we've got 80, and we've got our tangent line at the bottom here in red, and the chord for the angle 80 is going to be this light blue line here, okay? And the angle, that means, so what is the angle opposite this chord? Well, it's x plus 2y. So that must mean, if we take it over here, sorry, I'll write it in light blue, that x plus 2y is equal to 80 degrees, okay? Now let's have a look at the angle x at the bottom as well, okay? So we've got our tangent, and we've got our chord here as well, okay? And which angle is opposite this dark blue chord? Well, it's this one over here, okay? So that means that x is equal to 65 degrees minus y, okay? Now, hopefully you got this far. So if we got this, now if I rearrange, so some of you might have got this far, might not have figured out the next step, okay? But all I'm going to do, I'm just going to rearrange this dark blue equation, okay? So I'm going to add y to both sides. So I'm going to move this minus y over to the other side, and then see if you can spot what you have to do for this question then, okay? And if we rewrite the top one, x plus 2y. Let's rewrite that y a bit neater. Okay, so hopefully you can spot now that we've actually got a simultaneous equation going on here now, okay? So if you didn't get this far, or if you did figure this bit out, great, well done. If you didn't, pause the video and now try and solve this simultaneous equation, okay? So pause the video and then have a go at this. Okay, so I'm just going to run through it quickly. So we've got simultaneous equations. So we've got x in both of the top and the bottom equation. So I'm going to take them away from each other. X take away x is nothing. 2y take away y leaves me with y. 80 take away 65 is 15. So I found that y is 15 degrees. And then I'm going to substitute this value into one of the equations. I'm going to do x plus 2y. X plus 2y equals 80. So x plus 2 times y was 15, so 2 times 15 equals 80. Oops, sorry, 80. X plus 30 equals 80. So that means that x is equal to 50 degrees, okay? So a little bit of a trick there, thrown in a bit of algebra in there as well for you. But if you figured out that you were to solve a simultaneous equation, very well done. And even if you just figured out which angles were equal to what at the start of the question, very well done. Okay, so this is the hardest circle theorem, and hopefully I made it slightly easier to take in. Okay, good work today, guys, and I'll see you next lesson. Bye now.